Today, we are going to explore the ocean and learn how the ocean influences our ecosystem. First, we will start our virtual field trip by watching a short clip about Mission Blue, a story about world renowned oceanographer Sylvia Earle as she travels the globe on an urgent mission to shed light on the dire condition of Earth's oceans.
I see things that others do not. A different world. A world that's changed enormously just in my lifetime. My backyard was the Gulf of Mexico. That's where I first fell in love with the ocean. And I think if others had the opportunity to witness what I have seen in my lifetime from thousands of hours underwater, I would not seem like a radical at all.
It's a pleasure to introduce a scientist, an engineer, a teacher, and an explorer.
The ocean is dying. All of us, we are the beneficiaries of having burned through fossil fuels. But at what cost? 60 years ago, when I began exploring the ocean, no one imagined that we could do anything to harm it. I saw the after influence of what we can do to the natural world. Think of the world without an ocean. You've got a planet a lot like Mars. No ocean, no life. No ocean, no us.
In 1990, she became the chief scientist for NOAA, National Oceanic and Atmospheric Administration.
I went to one meeting, and I was never allowed to go again. I feel that I must resign, and as a private citizen, do what I can do with more freedom.
She's not afraid to say, you know what you're doing and it's wrong.
I really speak for the ocean. If we continue business as usual, we're in real trouble.
She's made it her life's purpose to make sure everybody else understands what's going on.
Sylvia has a wish for the planet, what she calls her Mission Blue. Protect the ocean in the same way we now protect the land.
I wish for a global network of marine protected areas to save and restore the ocean.
So, why is the ocean important? After all, we live on land, but our world is a water world. The ocean covers 70% of Earth's surface. The average depth of the ocean is about 2.7 miles. In some places, the ocean is deeper than the tallest mountains are high. The oceans contain about 97% of all water on Earth. The ocean plays a starring role in whatever happens with the environment. One big part of the role is it soaks up energy, heat, and distributes it more evenly around the Earth. Another part is it soaks up carbon dioxide. How does the ocean soak up energy? Well, how can a water balloon teach us about the climate change? Watch this video and find out more.
Climate change is something that affects all of our lives, whether we're a student, a teacher, or a scientist. Speaking of scientists, I have a guest here with me today that can tell us a lot more about climate change, Josh Willis. Now, you're an oceanographer here at JPL, correct?
Well, I'm an oceanographer, but I study sea level rise and global warming and really how the ocean fits into that whole global warming picture. Global warming is happening because people are emitting billions of tons of carbon dioxide and other greenhouse gases into the atmosphere. Now, when they get there, these greenhouse gases cause extra heat to be trapped on the Earth. So heat that would have otherwise been radiated back out into space is now sticking around and warming up our planet.
Now, all that heat is trapped in our atmosphere, but is it also affecting the oceans?
It turns out that 80 to 90% of the heat from global warming is actually going into the oceans. So the oceans are really the big Earth heat bucket. That's where all the heat winds up going. It turns out that the oceans can absorb 1,000 times the amount of heat as the atmosphere without really changing their temperature all that much. And the reason is because of something called heat capacity.
Do you have an example that could maybe explain heat capacity?
Let's imagine that this balloon represents the whole Earth's atmosphere. So now my candle, my little lighter here represents the sun, so let's add some heat to it and see what happens.
Now, don't try this at home without adult supervision and proper safety equipment. Whoa. So, Obviously, the heat capacity of air is very low because it didn't absorb any heat at all.
Well, that's right. Almost as soon as we put the candle to the balloon, it exploded. And the reason is because, since the air inside the balloon couldn't really absorb the heat that fast, all the heat went toward melting the rubber. As soon as the rubber melted, the balloon explodes.
Ah, okay, cool. Now that's a good demonstration of the heat capacity of air. How about the heat capacity of water or the oceans?
Yeah, let's do the oceans. How about a water balloon, Steve?
Sounds great.
All right. All right, Steve, so this balloon filled with water represents the oceans, and my lighter here represents the sun. Let's put some heat on it and see what happens.
Wow. Obviously, it's absorbing a great deal of heat.
Right, so you feeling the heat there, Steve?
I am.
All right, but the balloon really isn't, because it turns out that the water can absorb so much heat that it takes the heat away from the skin of the balloon before the rubber can melt, so the balloon doesn't pop.
Excellent example. So the water has a tremendous ability to absorb heat, and if that's an analog for our oceans, that means our oceans are absorbing a lot of heat as well.
That's right, they sure are, Steve.
All right, well, global warming sounds like quite a problem. What can we do about it?
Well, the first thing we need to do, Steve, is really just understand the problem. Scientists all around the globe, including NASA scientists and here at JPL, we study data from satellites that measure the oceans and the atmosphere, and these tell us about how global warming proceeds and hopefully give us an idea of what the future is going to look like.
It sounds like a pretty serious problem. What is it we can do?
Everything that we do almost uses some kind of energy, and most of it's produced by burning fossil fuels, which release carbon dioxide into the atmosphere. We could turn off the lights when we leave the room, maybe power down that computer every once in a while and go outside, take a bike ride instead of getting in your car.
Well, thanks, Josh, for coming in and talking to us today about climate change. We really appreciate your expertise.
You bet, Steve. My pleasure.
All right, thanks much. To learn more about climate change and how NASA and JPL are studying the problem, go to climate.jpl.nasa.gov. And for more information about what NASA is doing in general, go to www.nasa.gov.
The ocean does an excellent job at absorbing excess heat from the atmosphere. The top few meters of the ocean stores as much heat as in Earth's entire atmosphere. So as the planet warms, it's the ocean that gets most of the extra energy. But if the ocean gets too warm, then the plants and animals that live in it must adapt or die. Algae and plankton are at the bottom of the food chain. Plankton includes many different kinds of tiny animals, plants, or bacteria that just float and drift in the ocean. Other tiny animals, such as krill, sort of like little shrimp, eat the plankton. Fish and even whales and seals feed on the krill. In some parts of the ocean, krill populations have dropped by over 80%. Why? Krill likes to breed in really cold, wet water near sea ice. What would happen if there were no sea ice? What would happen if there were even very little plankton or krill? The whole food web would come unraveled. Coral is another ocean creature in trouble. Coral is a very fragile animal that builds a shell around itself. It lives in harmony with a certain kind of colorful algae. The algae makes food using sunlight, a process called photosynthesis. They share the food with the coral, and in turn, the coral gives the algae a safe and sunny place to live. The two of them get along fine, living in clean, clear, shallow waters where the sun shines through brightly. Fish love coral too, because there are lots of nooks and crannies for them to hide in. But the algae cannot carry out photosynthesis if water is too warm. The algae either die or the coral spits it out. Scientists are not sure exactly what happened, but it's bad for the algae and the coral. And the fish, the coral loses their colorful food sources and become weak. This sad event is called coral bleaching, and it is happening on a grand scale in many places around the world.